Oh boy. Hello everyone and welcome back to the shop. It's been a little bit of extra time since we've spoken. Walker, our incredible editor and media overlord here at LiftArc, has been in Bosnia. So he's been over there having some fun, traveling, seeing some people he cares about, and let's face it, I haven't had time to edit or film a whole lot. So I have managed to put myself in front of the camera. Well, we're gonna do a build today, but I also wanted to show you a few things, mention a few things that have happened. So other than Walker being gone, sad face, we have officially received our new order of LiftArc Studios long sleeve t-shirts. We have everything from, this is a triple XL and, this is a small. Sizes are pretty true to form. The one I am wearing is an XL tall. I only got 10 of these because on the polls I posted on social media and stuff, it didn't seem like too many people were really interested in tall sizes. I, for one, am incredibly interested in tall sizes because I am tall. And now my shirt doesn't, well, it still shows a little bit, but trust me, it's way better than it used to be. And look, the sleeves are long. So, but comment below if you would like some tall sizes. I have sort of a standing order with Press Merch, local merch supply place, and they can get tall sizes, no problem. But the shirts are for sale right now on liftarcstudios.com. I do not have a shipping and receiving department. I am packaging and shipping and labeling everything myself. So I just shipped out a big batch this morning. Thank you for those that have ordered so far, and appreciate your patience. I'm getting better at it. I got a stamps.com membership and stuff now, it's crazy. Also, I should mention that we are proudly supported by Arc3 Gases and Everlast generators, and now ShopSaber CNC. That is right, ShopSaber has officially come on as a partner, and we have some really exciting new technology that's coming into this shop that we get to share with you guys, coming from those brainiacs up north at ShopSaber. So look out for that. My table that I have will actually be going on sale soon. So let me know if you're looking for a 5x10 CNC plasma machine. I'll make you a deal. Also to my left, your right, is the Everlast 161 STH. This is an all DC TIG welder and stick machine. This is the one that Everlast wanted to send me when I compared the $200 VVOR welder to the $2,000 PowerTig 210 EXT. This is the one that's more comparable. This is like a $400-ish machine that is supposed to be feature packed, and I'm excited to get into it. Might be in this video, might be in an upcoming video, but I'm definitely excited to take this through its paces because this, if the DC TIG stuff is as good as the PowerTig that I have, this will be our new in the field welder. Like the railings that that are at the powder coaters right now that you saw us do in the last video. There's a lot of DC TIG that had to be done in the field, and a nice, dependable, feature-rich, light machine will be crucial for jobs like that. So we'll be unboxing this soon. And I think in the same video, I'm gonna be unboxing and trying out this really cool little device that was sent to me by a guy named Joe Uriarty. Hot Lights Welding. Joe hit me up one day and he told me about this really cool variable amp control that he makes for TIG welders. This one has the plug that's appropriate for the Everlast machines. It's sort of a really ergonomic, looks like a volume knob, so it's a variable amperage control, hopefully with an on-off switch built in. Looks like he's got two different kinds here. So shout out to Joe, Hot Lights Welding. Check them out. We'll give these things a run for their money soon. I hate most torch-mounted amp controls because they take focus away from holding the torch still, and it's a whole racket. So if it's super ergonomic and easy to use, I'm likely to incorporate it because it's kind of a pain in the butt to carry a foot pedal around as well. But anyway, thanks for dealing with me rambling. I just had to let you guys know of some things that have been happening since I saw you last, but we will push that off to the side. Without further ado, the main point of this video is a rather comical little thing that I need to do. You guys recognize what this is? This is a, cardinal directions on a stick with a ball. This is a weather vane, wind vane, whatever you want to call it. Normally mounted here is an arrow of sorts that when the wind blows, tells you which way the wind is blowing. This is how this one came to me. This one came from the one and only Robert Culp over there at Black Dog. And I'm going to use the powers of CNC plasma to cut a new arrow that we will mount on here. So this is a solid like 1/2 inch round stock. Got a little ball up here. We will end up having to cut this ball off. We'll cut the arrow on the plasma cutter. We will weld, either split the arrow and weld each half to like a tube in the middle, or weld the arrow to the side of the tube, probably split it. It needs to rotate around this axis, and we'll likely like weld like a washer, a support washer that can hold the tube and arrow, and then a cap washer to keep it from flapping around. And then we'll need to weld this ball back on, clean it up, paint it black, and get it out the door. So there you go. You're updated, you're up to speed, things are going well here at the shop, and let's get into making an arrow for this thing. So I gotta cut out this arrow, but I've also gotta cut out a second part to a sign that I'm working on. Thankfully, they can both come out of a 14 gauge plate. So I'm gonna load a scrap piece of 14 gauge on there, and a little shortcut to zero your plate. You know, I just use a nominal, actually I have 2 of these. Just something that you have 2 of, and you can put them in here as spacers. That'll do it. So now I'm gonna get the size of the available material I have right here, define that as a plate in the software, and then we'll map out our cuts. You guys know how this works by now, right? Yeah, you've been paying attention. So I've got 30.5 by 26. So I'm gonna go take that to the computer. Okie dokie. So today we're just gonna do this. So I have already forgotten my dimensions. 1 second. So now the arrow, the wind vane arrow. How do you do that? So here's what I did. So in Fusion, first of all, I found this picture online of a wind vane arrow. Don't know what it's from, couldn't tell you who it's from. Sorry if you're upset that I'm stealing someone's work. I don't really see it that way because somebody uploaded this to Google with a transparent background. But anyway, I figured this was a decent enough starting point. So what I did was I imported it into Fusion as a canvas. There it is. If you import it as a canvas, it's sort of this like transparent, translucent picture that sits behind your sketch. And what I did was basically I found a midpoint line. I oriented the canvas so it was like the center line was pretty straight, horizon-wise. And I traced the top profile of this, and then I mirrored those elements over that midpoint to create something that was symmetric. And then I did a modification of that down here to add like the sort of classic feathers on the back of it. So we have a solid and we have one that has like quote unquote feathers. And I talked to Robert, asked him which one he liked. I believe he said the bottom one. I'll check our text here in a second. But in any case, that's how I went from an image to an actual sketch in Fusion that can be exported as a DXF. Okay, so Robert did in fact want the bottom one. I just checked my text. So, what does that mean? Well, that means all we gotta do is, being that I'm not post-processing in Fusion, I know you can, and I'm hoping one day I will. Need to get some tips, take myself to school. But at least for my current workflow, I right-click on the sketch, I hit Save as DXF, which I've already done. And then I go into In Route, I've defined my plate, I go to Import, I go through my stuff, I find the DXF file, and bring that in. And here's the 2 arrows. I don't need the top one, so I can delete that. And it looks like everything look right. We've got double lines here, I think. Maybe not. So in Route, you gotta go to Transform and Merge Selection. And so now it's not a bunch of pink separate lines, it's one continuous blue outline. And that is to scale. It looks like 11.84. I think I was going for 12, so I can scale this. Let's just make our X dimension equal 12, apply. Now that thing is officially a foot long, which is what I was going for. And now I'm gonna import the other sign that I need to cut out at the same time, and then we will go to the cutter. This is a shout out for a local, I'm making an entryway sign for a local nonprofit, CHIP, the Child Health Investment Partnership, and they just had a big renovation, and their renovation and library, reception and library renovation brought to you by Delta Dental. So I'm making a little plaque to go alongside another big sign that I've been working on that I haven't been filming, but I'll kind of show you. I'm about to paint it, so I might as well just show it to you. Heck, maybe I'll show you how I paint it, because you haven't seen that. What a fun video. I don't have a ton of extra room. You know, I've got room for the sign itself and the arrow and maybe a few other things, but I feel like I'm getting my money's worth here for the 14 gauge. So we've got all of our parts set. The computer is on over there by the shop saver. Oh, Windows. You make networking so difficult. Let me fix this and I'll come back here. So I mentioned it before, but I'll say it again now. This machine is going to go up for sale very soon. In fact, I'd be interested in having discussions about that at any time from now until whenever, whoever sees this. Because I'm upgrading to the latest and greatest in conjunction with Shop Saver. I'm getting a new machine that it's gonna have some of the features that are included on newer machines. So we're getting to use my shop as a demo, not only to check out the new features, see what's up, but also to show you guys what the new machines from them are going to have packed into them. There's gonna be new motors, a new plasma consumable system, a bigger plasma cutter, deeper water table, bubblers, laser finder, engravers, all kinds of fun stuff. Can't wait to show you guys. There's absolutely nothing wrong with this machine, but I find myself in a fortunate position to be able to upgrade to the new one, and the shop gets the benefit as a result. So this machine is for sale. Hit me up if you're serious about it, we can talk. In any case, we'll do that thing we know we need to do. So this is 14 gauge. I cut 14 gauge with 45 amp consumables. 45 amps on the machine, 45 amps in the consumables. Now we got a 0, so the new machine's gonna have a laser pointer that'll help me make this process a lot easier. Because we're here and I've done this so much, we're just gonna do it. Align it with that edge, line it with that edge, done. Tell the software that that's our XY0. 14 gauge, DD plaque. Raise it up a little bit and let's go. See if it's gonna cut the arrow first. So there we are. Let's see how we did. Looks lovely. I will use my patent pending technique of scooping water out of the water table to clean off the carbon and whatever else is on the surface there. Some hangers on. Okay, look at that. There's a metal sign that we've made together. Let's dry this off, clean it up, then we'll put this on hold and we'll go back to making the arrow thing. There's the rough sign, and a wire cup on an angle grinder will get rid of most of the dross on the back. And really, that's all we're gonna have to do to this. It's getting painted a green color. We will just sand it with an orbital, ease the edges, acetone it, and spray it. So be spraying this tomorrow along with the other part of the sign that is dismantled right now. But I'll put this on hold, and we'll turn our attention back to the arrow here. So I wrote down 12 inches overall. That is a number that Robert and I came up with in the field, but it kind of looks a little rinky-dinky, doesn't it? I'm gonna text him a picture, see what he thinks. Well, look what we have here. A lathe. This poor old Hindi is pretty beaten and battered, but I do use it for small things. One of the things I use it for is drilling concentric holes in circular objects. More specifically, I have this piece of tubing that the ID is almost a 1/2 inch, and I want this to be the sleeve that the arrow is mounted to, probably by splitting the arrow and putting half here and half here. And this allows it to rotate around the shaft. This looks like there's a seam inside this tubing. So it's not DOM, it's just, you know, seam welded tubing. So what I want to do is chuck the tube up in here, like so, and chuck a 1/2 inch drill bit in here so that I can clear out, or ream out rather, the inside of the tube. Good old Morse tapers. Now there's a lot of difference between someone like me and someone like Curtis from Cutting Edge Engineering. If you haven't watched that channel, you definitely should. But I know enough about machining to be dangerous. So what I'm doing, I had to adapt this chuck to my tailstock. And so let's see how this goes. We're gonna go slow that down. Okay. See if we can't walk this guy in there. Just clean it out a little bit. It goes out quite a ways. So I know a drill bit is not a reamer. I know they serve two different purposes. That is a reamer, that's a drill bit. But this is a very imprecise exercise. I just want to make sure that we hollow the inside of that out enough to fit a 1/2 inch solid bar through. Oh, you guys are in the way. How'd we do here? Look at that. So this little pipe has gotten thinner, but that's okay. The inside is now 9/16 and should slide over that 1/2 inch pipe with a little bit of room to spare so it spins nice and freely. This is sort of our litmus test here. The 1/16 of play, but I think that's gonna be just fine for a wind vane. Here you go. Here's our margins. Obviously not a precise machine fit, but it's a wind vane. It's gonna be fine. I'm trying to knock it out quick. So no matter how many layers of paint are on the original one, this ought to slide over it just fine. For clarification, the idea is that this sleeve can now sit over this bar. And whenever we nail down the size of this, we can split this in half, weld each half to this pipe, cut this off, slide that over, bada bing, got a rotating thing. While I'm still waiting on the size of this to be confirmed, I'm gonna go ahead and cut this off and get a washer welded on to support this when we're ready to slide it on for good. Time for surgery. Okay. Kind of a blobby, gross sort of weld there. But see now, this slides on. Oh, I'm gonna clean that up. A little burr there. Eventually, that'll slide on. Let's clean these up. Clean all that up. Yeah. Get your mind out of the gutter, okay? Advanced sanding techniques. All right, let's test our theory. So that slides on good. Our pipe, boing, slides on neat, nice and free. So what we'll do, we'll have a washer, as I've stated, we'll have a washer down here, a washer up here. I'll probably just center this somewhere in here. So, find some washers that I have that might have a 1/2 inch hole in the center. It's one of my new favorite tools, a band file. Got this at Northern Tool and Equipment for like $100. It's a sander, but it's real tiny. It's air powered, obviously. I got a weld to this, so I'm gonna clean it up a little bit. Works out pretty good. I drilled these holes out of these washers on the lathe as well, and they're going to be a tight fit, but it should be plenty. Robert said he liked the size of this, so let's clean it up. Okay, got that. So we'll find a place to cut this. Probably gonna cut it a little forward of center because we want more of this to be behind so that when the wind is blowing, it's pushing the tail back further. If the tail is longer, that means the lever force from here is stronger than the lever force from here, so that it'll always point into the wind. At least that sounds good on paper. So instead of cutting it dead center, I'm gonna cut it a little forward of center, and that should do what we need it to do. Alrighty, so it's 12 inches long. 6 is the dead center. I already think there's more surface area back here than there is up here, so I'm only gonna upset it by a 1/2 inch. So I'm gonna cut it here at 6.5 inches. 1/2 inch forward of center. It's not gonna look too visually upsetting. And this pipe will help make this arrow wider because when I split it, it'll be welded to either side. Visually though, it'd be nice if it was in the center. I'm either gonna cut it on one of those two lines, either dead center or a little forward. Let me think on that. All right, we're back. We're gonna do a little bit of welding here. We're gonna weld the little washers on here. We gotta cut the arrow in half, weld it to the pipe, weld the top washer on, and then weld this little ball to the top. It's a bunch of small welding pieces here, but it's enough to where I feel like I want to test drive the new 161 STH DC TIG welder from Everlast. I was just about set up yesterday to do it with the 210 that I have, but why not? Kill two birds with one stone. I want to unbox this thing, and I want you guys to be there when I unbox it, and it'd be for an actual project. So seems like a good time to do it. Let me get set up here. We'll take it apart. What I'm hoping is that Everlast kept all the connections the same. This is my Power TIG 210 EXT that I bought a few years ago. And Everlast has, their standard quick connect gas situation, standard DINS power connector, and then the 7-pin remote connector. So I'm hoping that, I've built a nice collection of torches. I've got my little number 9 hooked up. I've got a CK Worldwide flex head number 17 that I use for just about everything. And I'm hoping that I can just reuse all this stuff. Hopefully, maybe even the gas line. We'll just see how consistent they've kept everything. So let's crack this thing open. I love unboxing things. Let's cut this open. We got custom stickers on here. Came from another country. Oh, interesting. It's got a case. It's like meant to be portable. That's cool. Well, that's nice because that's exactly how I intend on using this thing. Nice and simple. Let's open this up. Bum-ba-da-da. Loving this already. Love a good green machine. So the cool thing about this DC TIG and stick welder is that it essentially is supposed to have all the same functions as the more expensive machines. It just doesn't have AC. It's got a little less power, you know, than the bigger machines. But I think this is the kind of welder that knows its place, you know? Look at all that. We've got a front panel with a pretty surprising amount of features for a welder that's under $500. Ground cable, gas cable, electrode holder, classic gas flow regulator that comes with all Everlast machines. Love these, they do the job great. Okay, so it looks like it uses a smaller DOESN connector. Looks like it uses the same gas connector, the same control connector, but smaller dense plugs for the power. So I can't actually use any of my existing torches. I have to use the one that came with it. So let's see what came with it. So it looks like we just got a standard WP17 17 series rigid head torch with a trigger, of course the quick disconnect gas line, the plug, and the power. So this is sort of an all-in-one situation. Nothing wrong with a rigid head. The 17 series torch is gonna be plenty for the power this thing puts out. Looks like it did come dented a little bit in the top, but that's not too big of a deal. It can run off a 110 or 220. It does have a gas solenoid in it, so you know you can run it off of argon. You don't have to use like an inline torch argon valve or anything like that. So let's get this thing fired up and put it to work. I'm gonna take a second and clean the table here, swap my argon bottles around, and then we'll see how it does. Here's the machine itself. Isn't it cute? Check out the front panel. We've got 2T, 4T triggering, 2T, 4T triggering, live lift start, and high frequency start. We've even got a pulse. We can change hot start intensity, hot start time. That's all for stick usually. Oh, we can switch between modes here, stick and TIG. TIG pre-flow, TIG downslope, TIG pulse. We've got a percent on time, probably a background amps, and then a TIG pulse frequency. You can change the rod. You got 60-10. I don't know what VRD is, or anti-stick. It's probably for stick as well. You know, you got your standard push knob here, so you can do small adjustments or push it in and do bigger adjustments. This thing is tiny, y'all. Nice and light. Because this thing is sort of intended to be a mobile solution, I don't have a cart right now for it, and I'm not really gonna bother with a cart. I'm kind of just gonna set it on the table real quick and sort of do like a impromptu setup. One thing that's worth mentioning is, you guys remember that cheap and cheerful Vevor TIG welder that I reviewed not long ago? You know, I expressed my, well, happiness really with that thing, given the circumstances. This thing sells for $449, I think, right now on Everlast, which is about twice as much as that $220 Vevor unit. But if you just like feel the weight of this thing and just the build quality of the stuff it comes with, I think it's already off to a good start. I think for not much more money as far as welders concerned, we're gonna get a lot more out of a package like this. So I'm gonna hook it up, we're gonna plug it in and put it to work right away. Already this thing comes with a gas regulator, so that's an improvement from the Vevor for sure. Comes pre-installed with the 110 volt adapter. I am gonna run it off of 220 just because I have 220 right here and I wanna see what it's got. Pretty quiet right out of the gate, I'll say that. Got our amperage, change our process around, 2T, high frequency, that's really it. Amps, TIG pre-flow, do 0.3 seconds of pre-flow. I like a little downslope. Post-flow, crank that up to like 5 seconds or so. And then there's pulse, which is now on because I've gone there. Let's turn that off. And that's it. Very, very easy machine to set up. DC TIG does not require a lot of settings. So Everlast sells these Nova brand torches. I've used these torches for quite a while, and I don't mind them at all. In fact, every torch that I got with my original Power TIG 210 still works and you know, each one has its own specialty, so don't mind it at all. The cord is pretty thick. It's way thicker and stiffer than the super flex hoses you get from CK Worldwide, but it's okay. I think this machine would love to have a number 9 torch with it. Just a lighter duty torch for a sort of lighter machine. But here you can see the smaller DINS connector, power connector. Plug that in there. Turn that till it locks. Put in our gas, put in our trigger. One thing this thing can do over the VVOR unit is you can get a pedal for it. I have a pedal from the old machine, so I'm sure it'll work, which is nice. Pedals come in handy a lot. Let's get the ground undone here. Nice long ground cable, so that's helpful. I'll turn this back off for now. The gas hose in, attach the regulator. Oh boy, a lot of green in the shop these days, ladies and gentlemen. You know, I could see a reality now where I have a machine that's set up all the time to do DC, specifically thinner stuff. You know, it'd be nice to have a smaller unit set up to do like thin steel, and then the other unit's always set up either to do AC or stainless or whatever. Not that this couldn't do stainless. There we go. So we're set up. I'm gonna wheel this guy over and just hijack the gas supply. Shout out to ARC3 Gases for the lovely bottle of 100% argon. We officially have everything we need to start welding except for the torch setup. So again, 17 series torch, pretty standard stuff. You know what? I'm just gonna go ahead and use the consumables they provided. I never really do that. In the interest of a fair tool review, let's do that. I'm gonna set this thing up for a 16th of an inch tungsten. I'm gonna go with this number 6 cup here, just because it's bigger than all the other ones that came in the kit. I'm gonna set it up with this Arc Time stuff from Arc Zone. I'm gonna push the tungsten through this collet body, push that through the torch, poke out the end, put the back cap on. Pretty standard affair. There you go. Your TIG torch is set up. I could see myself putting a gas lens on this, a stubby gas lens. Shout out to Jody from Welding Tips and Tricks. He sells a really nice stubby gas lens kit. That'll shrink this down, give me a gas lens, and then you can cut your tungsten down and run a really short back cap, which will turn this big monstrosity into a nice little maneuverable TIG package. But in the interest of using what came with it for a full-on test drive, we'll just do that. So let's turn this on. Doesn't appear that this has a gas purge feature, so we'll just hear that high frequency working. Turn the gas on. Put it at about, I don't know, 17 CFH of airflow, and now we got it. You can hear it working there. So now let's get back to this little weather vane project and do some DC TIG. So we got our fancy dancy new TIG welder. You know, the VVOR unit is a cool party trick. Look what you can do with 220 bucks. But you know, when I'm building $10,000 railing systems in the field, I am not going to trust my entire job to a cheap little welder like the VVOR. Everlast has had my back for a while, so you better believe I'll be taking this guy into the field with me next time. Let's start some things up here. Clean my work environment. I've got 2 washers. Got one pre-installed here, so that's gonna be the first thing. I'm gonna TIG weld this washer on the bottom of the shaft. Then we install our rod. Of course, we'll weld the arrow to this first, but let's just do a nice little sample inside corner joint. Really just need to tack this, but we'll weld it up on this washer here. Let's set it to, try 60 amps. Yeah, do a little tacky tack. Feeling good. I'm gonna turn the amperage up a little bit, turn it up to 80 for my tacks. Pretty standard DC TIG performance. I'm gonna go up even more, go to 90. This 1/2 inch round bar is really sinking the heat. I should take a moment to verify if it's square or not. This cute, look at this cute little square. Thanks, Wyatt. It's doing what it should. So now that it's tacked, I'm gonna flip it over, put it like so, clamp the ground back to the table, get this figured out here, okay? And now I've got a much more comfortable welding situation. Dip my tungsten. Still think I need to go up in heat. Let's try 100 amps. That 1/2 inch round is just acting like a crazy heat sink. This is a rigid torch, but you can bend them all just a little bit. 100 amps feels pretty good. Keep rotating it. Nice smooth arc. Start. Guys, you know me, I am not a this is how to stack dimes kind of welder, but you know, you try to do your best. No reason this needs to have all this weld on it just to hold a weather vane, but we're testing out a welder. And I gotta say, folks, I like it. I mean, this is the only DC machine you'll ever need, unless you're doing real heavy stuff. I mean, 99% of the stuff I do in my shop is gonna easily be handled by 150 amps, which is probably where this thing tops out. Well, there you go. I got the bottom washer welded on, and this guy sits here. The other washer sits there. Then our arrow gets welded to that. Let's cut our arrow. I still haven't decided where exactly I wanna cut it, but it's time to make that decision. Let's clean this pipe up first. I love a fixture table. I'm just gonna cut this with a cutoff wheel. So that mark's in the middle. I think I'm gonna cut right in between those two lines. Just gonna use this cutoff wheel. No going back now. Got our 2/2 of the arrow. And now I hope you can see where this is going. We'll be putting it together like that. Some good little DC TIG opportunities here. Let me kind of clean these up. We'll get a spacer to space them up right. Oftentimes in fabrication, you have moments where you're trying to space something into the middle of something else. So in this case, I want the arrow to hit the pipe in the mid plane. So all you need to do is do a little math to find out the right spacer. So this pipe is 5/8, so half of 5/8 is 5/16. So if I wanted a spacer, I do this trick a lot. If I wanted a spacer to space these arrow elements up to the exact middle of this pipe, you gotta do a few things. You gotta start by finding the middle of the pipe, right? So what you gotta do is take half of the thickness of the pipe and half the thickness of the piece. 14 gauge is 0.078 inches, and this is 5/8. So 5/8 divided by 2 is 5/16, minus half of 0.078. So minus 0.039, yes, minus 0.039, 9/32. So to put this directly in the middle of that, we need two spacers that are 9/32. I'm just gonna grab some drill bits. So grab two 9/32 drill bits, and there you go. That'll guarantee that that is in the middle of that. And I can put a clamp here, put a clamp here, tack, tack, flip, weld, weld. You get the idea. So let's establish our midpoint. God, this Vevor stool has fallen apart already. This is a 4-inch pipe, so our midpoint here is 2. So we'll make a mark there, kind of just eyeballing this. And then this piece here is, well, right at 1 inch. So mark our 1/2 inch midpoint on that piece, mark our 1/2 inch midpoint on this piece. We're ready to go. Take 2 stops, figure out where I've got some holes. There's one there. How have I not reamed all these holes out yet? It will be 10 years, I'm sure, before I have all these reamed out. Well, those all seemed reamed. Why did they not fit? Is that one not reamed? Sure wasn't. We'll use those stops here. We'll get our drill bits. We'll put that there. We'll get a clamp ready. Okay, push that up against there. Do a little clampy. We'll do a little jiggy. See that? So now we've made a little jig. Drill bits, you know, if you have a whole drill index, they make for great spacers. Not perfect because of the flute, maybe blades on the flute, but this is a wind vane, so we'll be just fine. So I'm gonna tack this, and then we'll flip it over and do the same thing. Cue the Everlast. I'm gonna turn this amperage down back to 80 because I don't have a giant heat sink like I did before. Okay, just gonna tack on each end like that, like so. You can see it's pretty much right in the middle of the pipe, which is what we were going for. Now, I'm gonna move the stop over. Oh, look at that, it fits perfect. Okay. So same thing here, except I need to support this side now too, so I'll get one more drill bit. Luckily, I happen to have 3 9/32 drill bits. Okay, so we're gonna do that. Bring this over here, clampy, push this over, hold this down, and make sure that everything's looking okay. I'll give it the old eyeball test. We'll get another clamp. I've been sitting over here listening to the Everlast hum. It is way quieter than my Power TIG 210, which is nice. We're good there, so I'm gonna tack this up as well. All right, let's give it a visual inspection here. I think that'll do. That's kind of cool. It's perfectly in the center line. You see that? Our spacer method worked great. So I'm gonna clamp this back down and put a bead on the backside. Cute little weld. I rotate this thing around to get in here. Love the downslope. Always a nice feature to have. This part is now heat soaked. So I actually bent it. All right. Got a little bit of undercut. That's okay. I'm gonna turn it up just a hair. Let's try the pulse, actually. Pulse hertz starts at 250. Let's do like 0.8 seconds. Is this seconds? On time in seconds. Half a second. I don't know what I just set up, but let's try it. Nice pulsar, nice and quiet, doing what it's supposed to do. A little shaky this morning, but blame that on the coffee. Man, I love a good pulsar. There you go. Got a weather vane arrow. Welder did good. Again, I'm not a dime stacker by any means, but it's strong and it's gonna do the job. So now we just get this top washer welded on and we're done. Look at that. I actually hate how big those washers are. I might end up cutting it down and making it smaller. It's okay, we'll get there. I wasn't gonna show you me shaving this washer down, but I just came up with a funny idea. If I spin it with the drill and sand it with this thing, this is so dangerous. It's getting smaller. That looks better. Whoa! Don't try this at home. All right. It's a lathe, kind of. So now I've done the same thing to the other washer. Actually, I'd like to go more. The other one I had sandwiched between 2 nuts on a 1/2-inch bolt and put it up against the belt sander. I'm gonna go do that again, get it down to the same size. I like that size. much less noticeable. I wonder if it works as a wind vane. I don't think that's how that's supposed to work. How do you test a wind vane? I don't think it works as a wind vane. Well, I'm gonna go make it smaller first in case it gets stuck on there again. All right, I made that a little too small. That's okay. Alrighty, insert this. It's gonna get stuck again. I mean, just please go on. How is this happening? Oh, I guess we'll use a file. Gotta be a burr or something. On today's episode of Lift Arc Builds, watch Tay try to get a washer on a rod for an hour and a half. You have got to be kidding me. Why is it so tight? Come on. Put it in a vise, use a file. All right, come on. There we go. Guys, we did it. We did it. Counter spin. All right, I'm gonna get 2 pieces of shim stock, put them under there. By shim stock, I mean metal banding. I think I'm just gonna cut. Oh, I know why that didn't fit. That was a different washer. This is the one I sanded down. I am an idiot. Well, whatever, we'll use that now. I'm gonna make a spacer. So I've cut a washer into a U shape so that that's gonna be my spacer. Love that. All right, we'll get our machine fired back up here. I'm gonna turn pulse off. I'm gonna go up to 100 amps. Hook the ground to it. Grab this terrible stool. No, it burned through. Ah! I need to focus more of the heat on the pipe itself. Proper application of heat is the secret. Love it. All right, that's on there for good. Time to weld this ball on here. Just gonna kind of guess on that. Gonna turn this machine up to like 100 and call it 120. Probably more power than you should run through a 16th inch electrode. But YOLO, just kind of hold this here. Got a little tacky tack. Ow. Don't use a fresh weld as a hand rest. Gonna have a bad time. Okay, ground it again. Find something to rest my hand on. Nice Milwaukee drill there. Let's weld it up. Ah! Love it. Alrighty, there it is, ladies and gentlemen. Weather vane repair. We've done it. There we go, all welded up, perfectly functional. I'm not a dime stacker, but it's gonna do just fine. Time to paint it black and get it out of here. Big shout out to the new Everlast 161 STH DC TIG welder. Been a pleasure using this thing. You know, it's 1/3 of the size of this bad boy. Much more portable, ready to go, feature packed. Love the pulse, love the arc stability, love the trigger, love the high frequency start, love that I can put a pedal on it if I want to, love that it came with its own gas regulator, and I love that you guys can get it for $440 some. That is a freaking deal at twice the price. Go check it out. Special thanks to Everlast. As always here at Lift Arc, we are proudly supported by Arc 3 Gases, Everlast Welders, and Shop Saver CNC. Thank you so much for watching. Fun little build. I'm gonna paint this thing real quick and maybe we'll give you guys a reveal. So in that case, the video is not over. But anyway, that worked out well. That was a fun little hour. Making a silly little thing. How about that?